So when we were talking about viscosity, we have found the formula that tau is equal to mu du upon dy, where mu is called the dynamic viscosity. Please be very clear that whenever you are being told that this is the value of viscosity, by default it is giving you the value of the dynamic viscosity or the coefficient of viscosity. All three names standard are considered for the dynamic viscosity. Now let's look into the unit of mu, unit of dynamic viscosity. From here, the equation you can say that mu is equal to tau into dy by du. Tau, what's the unit of tau? It was Newton per meter square. Distance is having a unit of meter and u is having a unit of meter per second. So second goes on the top. Meter cancels out. So mu is having a unit of Newton second per meter square. Since this fluid mechanics is a very old concept, earlier we used to have a unit called poise. And how are they rated is that 10 poise is equal to 1 Newton second per meter square. This is very important because usually when we go for the competitive examinations, the dynamic viscosity, just to check the width of your knowledge, is given in poise. So using this conversion, you can convert it. There is also other unit of this viscosity. We called it, we have talked about dynamic, this is kinematic viscosity. So this is defined as nu, and nu is mu by rho. So mu is dynamic viscosity and rho is your density of the liquid. Please remember this term is nu or NEU. Initially what we were using was for the specific weight was gamma. So there is a circle over here. So this is gamma and this is used for specific weight. I would make sure that gamma would have a small circle in between and nu won't be having any circle. So these are two different notations. So why the concept of kinematic viscosity? Because kinematic viscosity is actually normalizing the value of dynamic viscosity. See, the dynamic viscosity will vary as per the liquid density also. So now if we normalize it with respect to density, so we will be getting a more usable value which we call kinematic viscosity. So now if I want to find the unit of kinematic viscosity, the unit of dynamic viscosity is Newton second per meter square whole divided by the value of density is kg per meter cube. Now, if I break the unit of Newton comes from force, and force is equal to mass into acceleration. So Newton is actually kg meter per second square. So if I substitute over here, so this will be kg meter per second square into second into meter square. Over here meter goes up and kg goes down. This is meter and this is kg. Kg cancels out. And over here second cancels out. I'm missing something. Kg per meter cube. This is meter cube. So this value again, look over here. So this meter square, meter cancels out. So this comes out to be meter square per second. So the unit of the kinematic viscosity is meter square per second. Similarly, as we have talked about the dynamic viscosity, the kinematic viscosity used to have a unit of Stokes, and 10 to the power 4 Stokes is equal to 1 meter square per second. This conversion is also important. The numericals, a good practice sheet of numericals will be uploaded on with the upcoming lecture.